Hello everyone, my name is Suparsho Patil and today I will be presenting on the topic Applications of RNN in Text and Time Series Data. Recurrent neural networks or RNNs play a major role in modern AI systems that deals with sequence-based information. Why do RNN applications matter? Many real-world problems involve sequential data such as text, speech, stock prices, climate readings, etc. So the traditional ML models fail to capture order, context, and time dependency, but RNNs handle sequence effectively. RNN applications like Power NLP, virtual assistants, financial forecasting, healthcare analytics, IoT time series monitoring, and more. For example, Google Translate, Siri, and stock price prediction use RNN based architectures for sequence understanding and forecasting. So, what are RNN applications? RNN means recurrent neural network, are neural models designed to process data with sequences where current output depends on previous inputs. There are two major application domains in RNN. First is text based, that is natural language processing, and second is time series based, that is forecasting and prediction. RNN variants like LSTM and GRU enhance performance by solving long-term dependency problems. For example, ChatGPT, Google Assistant, and predictive typing rely on RNN-based NLP systems. Now we see where RNNs are used for text-based tasks. First is sentiment analysis. Analyze text emotion in movie reviews or social media comments. Second is machine translation, that is used for language conversion. For example, language converted from English to Hindi. Third is text generation, like story writing, code generation, auto completion, and chatbot responses. Fourth is speech recognition and conversational AI, that is smart assistants like Siri, Alexa, and Google Assistant. Fifth is named entity recognition, that extract names, places, products from text for business insights. For example, YouTube comment sentiment classification to detect user satisfaction. Now we see where RNNs are used for time dependent data. First is stock market and financial forecasting, that predicts price, trends, return, and risk. Second is weather and climate prediction, that predict temperature, rainfall, and environmental forecasting. Third is health monitoring, for example IoT plus AI, that detects heart rate, glucose level prediction based on past readings. Fourth is energy demand and load forecasting, that predict electricity consumption and power load. Fifth is anomaly detection in time series, that like fraud detection in payments, network intrusion alerts. For example, LSTM based model predict future COVID-19 cases using historical daily data. Now we see how RNN applications work. RNN process input one step at a time, maintaining a hidden state to retain memory of previous steps. For text tasks, tokens or words are fed sequentially to learn grammar, context, and meaning. And for time series, historical values are fed in order to learn patterns and forecast future outcomes. LSTM or GRU networks improve performance by storing long-term information and preventing vanishing gradients. For example, to predict tomorrow's stock price, an RNN takes the past end day prices and learns the pattern over the time. Now we see challenges and limitations where RNN struggle. In long-term dependencies, like standard RNNs forget older information, where LSTM or GRU needed. Second is slow training. Sequential processing makes RNN computationally expensive, not best for long sequences like transformers outperform RNNs in text tasks. High data requirement. Time series forecasting needs large, clean data for accuracy. Example: standard RNN fails to translate long sentences effectively because it cannot retain context throughout. Now we see summary. RNNs are powerful for text and time series because they learn sequential patterns over time. It is widely used in natural language processing like translation, chatbots, sentiment analysis, and forecasting like stocks, health, and weather. LSTM or GRU improve RNN performance, but modern models like transformers now outperform RNNs in many NLP tasks. Example: Indian stock market forecasting and ChatGPT style NLP system evolved from RNN foundations.